Hello everyone, myself Dr. NCH Ramgopal, working as Associate Professor in Mathematics in the Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. I welcome you all to the today's session on Cauchy's integral theorem, verification of problem 2. In the last session, we have verified a problem. We have verified the Cauchy's integral theorem for the given f of z. So some f of z will be given. Now we verify the theorem. That means whether the theorem statement holds for this function on the given interval of limits or not. So for that we need to find the line integral of that function, and finally we have to show that the line integral is 0 along this curve C. Now coming to this problem number 2, show that the line integral of z plus 1 is 0 where C is the boundary of the square whose vertices are the points. So here given integral z plus 1 dz. So here the function f of z is z plus 1 and the curve C is a square with the points z equal to 0, z equal to 1, z equal to 1 plus I and z equal to I. And here we have the complex variable z is in the form of x plus iy. So f of z can be written as x plus iy plus 1. Now from this we can find dz also. So dz is dx plus I dy. And we need to find the LHS, integral f of z dz, and to prove that LHS is equal to the RHS 0. Now first, the curve C is a square with vertices z equal to 0. So that means the point 0, 0 and z equal to 1. So the point 1, 0. 1 plus I. So 1, 1 point. And the last one is I. So 0, 1 point. So O, A, B and C. So the square is with vertices O, A, B, C. Now to evaluate the line integral along C means the evaluation of line integral along OA, along AB, along BC and along CO. Now we need to evaluate these line integrals one by one. Now the first one, along OA. Along OA, here we can clearly observe that the value of y is 0 on x-axis. The value of y is 0 on x-axis. So along OA, y is 0 and x changes from, here you can see x equal to 0 to the line x equal to 1. So x changes from 0 to 1. If y is 0, what is the value of dy? dy is 0. Now dz is dx plus I dy. Since dy is 0, this is equal to dx. So therefore along OA, f of z dz is equal to, along x from 0 to 1, what is this f of z? F of z is x plus iy plus 1. But along OA, the value of y is 0. So only x plus 1 remains, dx. So which is x squared by 2 plus x from 0 to 1. The integration is simple, very simple. And after applying the limits, 1 by 2 plus 1, which is 3 by 2. Similarly, the second one, along AB. Along AB. So along this line, here it is very clear that x is 1 and y changes from 0 to 1. So here x equal to 1 and y changes from 0 to 1. If x is 1, dx will be 0. Then dz is I dy. So actually this is dz. Since dx is 0, dz is I dy. And therefore the line integral along AB, f of z dz will be x plus iy plus 1, but x equal to 1, so iy plus 2. iy plus 2 dz is I dy. And here I comes out. So iy plus 2 dy. So that is equal to the integral of iy is I into y square by 2 and integral of constant is 2 into y from 0 to 1. Therefore, by applying the limits, here upper limit is 1, so which gives I by 2 plus 2, lower limit is 0, so simply the answer is 0 for lower limit. Now, by multiplying with I, the answer is 2i minus I square, 2i plus I square by 2, but I square is minus 1, so 2i minus 1 by 2. Similarly, we need to evaluate the line integral along the remaining two lines, BC and CO. Now the third one, along BC. Now along BC, here it is very clear that this line y equal to 1 is fixed one and x is changing from 1 to 0. So along BC, y equal to 1. Y equal to 1 and x changes from 1 to 0. If y is 1, dy is 0. Therefore, dz becomes only dx and integral along BC f of z dz is equal to x from 1 to 0. What is f of z? X plus iy plus 1. But here y equal to 1. So, x plus 1 plus I. X plus 1 plus I. Dz is dx. So, by integrating x square by 2 plus x plus ix from 1 to 0. For upper limit we get 0 and for lower limit minus 1 by 2 minus 1 minus I. So, the answer is minus 3 by 2 minus I. Now, coming to the fourth side along CO. Here, along CO, the value of x is 0 and y changes from 1 to 0. If x is 0, dx is 0, then dz will be I dy. Therefore, along CO, f of z dz is equal to y from 1 to 0. What is f of z? So, here x is 0, so iy plus 1 remains, iy plus 1 into I dy. So, which is equal to I into y square by 2 plus y from 1 to 0. So, I into upper limit 0, for lower limit minus I by 2 minus 1. So, this is minus into minus I into I minus I square, which is plus 1 by 2 minus I. So, we have all the four line integrals along each side of the square. Hence, the LHS is the line integral along C f of z dz, which is along four sides of the square. So, along OA plus along AB plus along BC plus along CO. Now, along OA and AB, the values are 3 by 2 and 2i minus 1 by 2. 3 by 2 plus 2i minus 1 by 2. Along BC, minus 3 by 2 minus I. So, minus 3 by 2 minus I. And the last one is 1 by 2 minus I. So, here 3 by 2 minus 3 by 2 gets cancelled. Minus 1 by 2 plus 1 by 2. So, 2i minus I minus I. Minus I minus I minus 2i. So, the answer is 0. Therefore, the line integral f of z dz along the given curve C is 0. So, today we have verified Cauchy's integral theorem for the given function f of z. That means we have proved that the line integral C f of z dz for the given function is 0. So, this is for today's session and we will discuss about the Cauchy's integral formula. Cauchy's integral formula in the next session. Thank you very much.